You launched an e-commerce website and one day you woke up to this situation. Your website is down as your brand is suddenly famous and your users are running around. I know it feels disastrous as it would bring lot of bad media attention for your brand and lot of unwanted words of mouth. Well, we can stop this disaster by preparing well in time and coming up with right systems architect. Let's start our journey to learn system design. Hi, I am Pradeep Kumar, a student of technology with you in this video. We are going to learn about the nitty-gritties of designing scalable software systems in this video series. Let's dive in this together. Before we start, I want to let you know that I am learning system design from this particular book having title System Design Interview, and it is written by Alex Zhu. If you want, you can get a copy of it from Amazon. Okay, let's start. In this video, we are assuming that the website that we built is mysite.com, and as our business is growing and numbers of users are increasing day by day, we need to take some steps in updating our systems to cater to changing needs of the business. In this video, we would see how we can launch mysite.com with single server setup. Once we start acquiring users, we will move the database server to a different server. As the number of users go further, we would need to add new servers or scale out our servers. Once the load on our DB server is reaching the limits, we would introduce DB replication in form of master-slave setup. After that, we would see how we can improve the response time for our users using different caching techniques, and this improvement will be continued as form of CDNs, which will be used for delivering the static content to our users. Once we plan to go multi-country, we would need to introduce multiple data center, and we will have a look on how we can do geo-scaling. To scale further and become fault tolerant, we would see how queues can benefit our systems in decoupling from different systems. To start with, or to launch mysite.com, we can get a EC2 instance from AWS or get a shared or dedicated server from BigRock, GoDaddy, or HostGator or any other web service provider company, and install all the components that we need like database server, application server on the same machine. So this same machine will cater to mobile application traffic and as well as the traffic from web browser. When we launch this, the typical flow would be any user will request mysite.com if they are coming from web browser, or if they are coming from mobile application, which will internally use APIs which will be hosted on api.mysite.com. The DNS will send back the IP of our server to the user, and then this user will send the request to our web server. Once we get the request on web server, it will respond back in the form of HTML page or in the form of JSON, that is JavaScript object notation for mobile app. This kind of setup is also known as monolithic architecture, and it has some drawbacks like limited scalability, availability, or flexibility. If our web server is coming down, it will bring down all the components of our software system architecture, which are database server and application. This type of architecture is good for very small systems. This type of single server setup architecture can cater mysite.com for the initial days, and once we start acquiring users, we will have to move out our database server from the web server. So our new architecture would be looking like this, wherein the user is coming to web server with their request, and web server internally is calling database server which is hosted on a different machine. This type of architecture will give some improvement in terms of flexibility, security, and scalability of the system. For example, if we are using MySQL or MongoDB as database system, we can do a different setup in terms of configuration for this server so that it would be more secure and no user from the outside world can access our database directly. This type of architecture, wherein we have one web server and one database server, both talking to each other and serving the end users, can cater the users and growth requirement for few months, but later on we will have to scale our servers further. Before we move further, we need to understand the concept of vertical scaling and horizontal. Vertical scaling is one way to increase the capacity of a particular server by increasing CPU cores, RAM, or the size of disk available for that virtual or physical machine. Horizontal scaling is something in which we generally add more servers. Vertical scaling is done for the application that experience a steady, predictable increase in the traffic. And if there is sudden increase in the traffic which is unpredictable, horizontal scaling is something we go with. Let's move ahead and understand the concept of load balance. When we add multiple servers, you might notice that the DNS has entry for the target server. So we cannot have multiple IPs in DNS. And we need a system which can balance the load between multiple servers that we have in the server pool. So load balancer is something which will distribute the load evenly to the available servers in the pool. It is a reverse proxy technically, and HA proxy is one example. Okay, coming back to our example of mysite.com. Now number of users has increased. So what we are going to do is we have added two servers. Earlier we had one server which was directly connecting to the users, but now we have a load balancer in the architecture. So the IP that we put in the DNS will be of load balance. Now the request will come from users to this load balancer, and this load balancer will send the traffic to either server 1 or to server 2 on the basis of round robin algorithm. And there are some advanced algorithm wherein load balancer sends the traffic to the server having the lowest. Now advantages of this setup are, if one server is down, we can very easily serve the user with server number 1. So this provides some fault tolerance to our users or to system. Now we have scaled out our web servers, which means we have added additional servers to the server pool. This will increase our capacity in terms of serving the increased traffic. Now we also need to do something on database layer because we have only one instance of database in our system. Before scaling the database layer or the database tier, let's understand about different configuration that are there for database. Database configuration comes into many mode, which are master slave replication, master master replication, or multi-master replication. But in our case of mysite.com, which is an e-commerce website, will have so many reads and few writes. So database master slave configuration is such a configuration wherein we have one master database which will take write queries like insert and updates from the web servers, and there will be multiple slave DBs which will take up the read queries like select from the pool of servers from web server. Now when we fit in this DB master slave configuration in our architecture, the whole architecture will become like this, wherein the user will request the DNS. The DNS will send back the IP address of our load balancer to the user, and then user will send a HTTP request to the load balancer, and load balancer will send this request to the available server in the server pool, and this server will figure out whether this request is for write or for reading from the database. If it is for write, the server 1 will send it to MasterDB, which is supposed to take all the write queries. and if this particular request is for reading anything, it will go to slave data. Over here, you might see that we are calling the pool of servers as web tier and the pool of database as data tier. This is some sort of standard terminology that we will come across. Once we have master slave configuration at the database tier, we can serve more number of users because there will be segregation of write queries and read queries, and we will have multiple database servers which are synced. This architecture can handle very handsome amount of traffic and is fault tolerant at the web tier level and also at the data tier level. Let's assume if this server goes down, all the read queries will go to master. So our system is fault tolerant and it would be very highly available for the end user. Now we have a system which is fault tolerant as well as very highly available. Let's see how we can make the response time of our system a little bit faster by using caching. Caching is a technique used to temporarily store frequent access data in a faster storage medium such as memory or in file system or in database. For our use case, we will do caching of database queries on the web server levels. So the logic in implementing caching is generally if the data is in cache, we will read the data from cache on the web server and send it back to the user. If the data is not found, which is called a cache miss event, we will read the data from database and then write it into the cache and then send the response back to user. We will see in a bit how the architecture would look like. As we are caching the queries for database, which will reduce the load on database, we can introduce the concept of CDN to reduce the load on our website. CDN or a content delivery network is a network of servers which are distributed geographically around the world, and they are used to serve the static content on our website or app from the nearest server from the user. These static contents can be images, CSS files, or the compiled JavaScript. CDNs work similar to cache work. Once a user will request an image from CDN, if it is found, it will go back to user. If it is not found, the CDN will request the image from the backend server and then store in the CDN, and then it will respond to the user. Now after implementing both the CDN and caching, this is how our whole architecture will look. Now the user will get the static content from CDN, which will reduce the load on our web servers, and once the request is at web tier, it can very easily check if the response data is available in cache. If it is available in cache, the server will read from the cache and then respond back to the user. If it is not available, it will read from the database and then write into cache, and afterwards it will respond back. The CDN will reduce the load on web server because the static content will be served to user from the CDN, and this cache, which can be in form of file system cache, in-memory cache like memcache, or it can be a standalone server like Redis also. So introducing the cache will reduce the traffic and load on our database. This would make our system highly scalable, available, and fast enough to meet the user needs. Let's say your business is doing really good and you acquire a lot of customers and the traffic is increasing day by day. Now you have decided to go international, and by that we mean that you want to serve customers of different countries. To do so, what we can do is we can include the concept of geoscaling, which means we will create our data center in different part of different continents wherein we are providing our services. For example, let's say mysite.com was available in India and now we want to go to international in US market. In US, we will create two data centers, one in US East and another in US West. Now, whenever the request from US will come, The load balancer will geo-route the request from the user to the nearest data center. Geo-routing is service from DNS wherein it routes the traffic to the nearest server on the basis of user's location. So in this manner we can have multiple data centers and provide faster response to the end customer. Because if we are serving to US customers with the data centers present in India, it will take a lot of time when the request is traveling from Indian oceans and different continents. One smart way of doing it is to create a data center in US East and another one in US West, so that we can provide them faster responses with higher scalability and flexibility of our architecture. When we create these data centers in multiple regions of the world, this not only caters the requirement in terms of flexibility, scalability, it also helps in complying with local laws. For example, there are certain countries wherein they want the data of their users or their citizens should be processed and saved in the same country. Now your business has gone international and it is doing really well. Now your business development team will do different collaborations with other companies which will take data from you in form of different events, or you will take data from them in form of different events. For such cases, we can introduce the concept of queues. Queues are software architecture components which help in decoupling different systems. The queue acts as a buffer between the message producer and the consumer. Producers and consumers are the application which send message to the queue and which consume the message from the queue respectively. For example, if my site is sending some messages to Zomato, for example in India, so mysite.com will be producer and Zomato will be consumer of the message queue. Message queue can be used for variety of purposes like decoupling these systems, load balancing and handling burst of traffic. These queues allow for asynchronous communication between systems so that if one system is busy or unavailable, the messages will be stored in the queue temporarily and will be delivered when the other system is available. Apache Kafka, RabbitMQ, and Amazon SQS are example of queuing system. With the introduction of queues in your system, you will be interacting with other companies or systems and it will decouple your system from them as well. So here we are and I congratulate for the million customers. These million customers I know are imaginary on mysite.com, but all the learnings that you had till now is very real. Congratulations on that. And the next step would be to introduce some concepts like database sharding, microservices, and others. Because computer technology or computer infrastructure technology is evolving day by day, and different cloud vendors are offering different systems to easily scale up your systems to make it more robust, to make it more scalable, to make it more secure. So think about it, what you would like to do next in your imaginary mysite.com. Okay, so I think you had a good learning till now, and let's take this question. We received an alert for 90% CPU utilization of server in a single server setup. What would be your step to bring the server back to healthy status? Think about it and put in your comments as answers. I will provide the answers to these questions towards the end of this series. Have fun, keep learning, and I'll see you soon in the next video.